Hey everyone, so in this video today we're going to be looking at the bromination of a carrot. So specifically looking at this molecule, I have drawn twice on here, but you'll see why I have the second one. This molecule on here called beta carotene. So beta carotene is the molecule that's responsible for the color of a carrot, so that bright orange light or light that's reflected. So how this works is the molecule beta carotene actually absorbs light and goes to a higher energy state and then emits the light out. And the light that it emits or reflects is the color that you see. So what is responsible for that color is actually this pi system is what we call it. So all these double bonds that are lined up in a row is called a pi system. A pi system. So this pi system is responsible for a lot of different colors. So if it's a little shorter, it'll change the color. If it's a little longer, it'll change the color again. And how long that what we call conjugation or pi system is what causes this color that we see. And so beta carotene, as you can see, has, I don't even know how many double bonds, all these double bonds in it. So a test that we can do to see if there is beta carotene in something is to react that molecule. So specifically what we're going to do in this experiment is we're going to see what happens when we mix this pi system or these alkenes like we've been talking about in chapter 11. If we mix these alkenes with bromine and do a bromination reaction, does it remove the color from beta carotene? So specifically, we're going to take this molecule and we're going to mix it in bromine, which is Br2, in water. This is not a reaction we specifically learned, but it's pretty similar to like halogenation, except we're going to add a bromine on both sides of the alkene instead of just one side. So there's lots of alkenes to choose from, and this is why I redrew the molecule here or copied it. But let's say that we reacted this alkene in the middle. In a bromination reaction, we would add 2 bromines across that alkene. Now we're disrupting our pi system. So we have one pi system on this side, but now it's not connected to the other side. And when we disconnect them, it changes the light that is absorbed. And if you make it too small of a pi system, then you no longer see it as light. It gets down into like the like UV active range instead of the visible light range. And so it will just, the color will disappear. So what we're going to do is just try this out. I'll cut to a video in the lab of me adding a carrot that is peeled into some bromine water, and I'll see you guys there. See what happens. Okay guys, we're going selfie mode for the lab portion of this because coronavirus and I can't get near to anybody. So what we have here, welcome to the Brown Lab. Say hi to everybody. Beautiful. So what I have here is I have a carrot that I peeled, and I cut this piece that we're going to keep as our control so we can compare. And then I have these 2 pieces of carrot, and I have a solution of bromine and water, just like I showed you guys on the board. And all I'm going to do, first off, notice that both are orange, just so that we realize that we're not like dyeing anything. We're actually doing a chemical reaction, right? So to start off, we have both things as orange, and I'm going to submerge these pieces of carrot, and I'm going to leave them for about an hour. We'll leave this guy here out of the bromine water. So I'm going to submerge them for about an hour, and I will keep up with you. Let's see what time it is. It is 9:15 in the morning, so I'll see you guys at 10:15. Okay, y'all, so we're back. Admittedly, it's been a little bit over an hour. I got stuck in a meeting, but that's okay. So let's see what happened. Okay, so here is our carrot that has not been reacted at all, just for reference. So let's take these guys out and see what they look like. Okay, so let's get this one too. As you can see, the carrot is now white. I think in the center it's probably still pretty orange. So if I cut it apart, once I have two hands again, I'll cut it apart and we'll look in the middle. But everywhere that the bromine was able to reach the skin or the meat, I guess, of the carrot has turned like a yellowy white color. It's gotten rid of its orange color. I'm going to take a moment and cut one of these apart and see what they look like on the inside. Okay, so I cut apart this little guy here, and as you can see, you can tell where in the carrot has been reacted. So you can see how deep it has gotten. So that's why you can still see kind of a yellowy orange hue through it. But it's definitely completely white on the outside and our normal orange carrot on the inside. It's pretty cool.